Building your own camera drone might sound like a complex engineering project, but it is much easier than you think. You can build a fully working camera drone in about 30 simple steps. This guide will walk you through the entire process. We will cover everything from unboxing the parts to your very first test flight. The main goal is to take simple, affordable parts and turn them into a quadcopter that can fly and record video. This is a fantastic way to learn about electronics, mechanics, aerodynamics. It is incredibly rewarding to see something you built take flight for the first time. We'll make this journey clear and straightforward. Before we begin assembling, let's talk about parts and tools. We're using a simple drone kit to keep things easy and affordable. Tech Supreme RC Quadcopter 360 Flips. DIY drone kit, around rupees 2,500. E88 Max drone camera, about rupees 300. You will also need some basic tools you might have at home. Small screwdrivers, pliers, hot glue gun, wire strippers, zip ties. Recommended battery, 11.1 V, 1500 mAh, 3S LiPo. These are the components you need to get airborne. Safety is the most important part. We're working with electronics, batteries, fast-spinning propellers. Always work on a clean, non-metallic table. Keep small screws and parts organized in a tray so you do not lose them. When it comes time to handle the LiPo battery, be very careful. Never charge it on a flammable surface like a carpet or a wooden table. It is best to use a fire-resistant LiPo bag for charging. When testing motors, wear eye protection. Propellers spin incredibly fast and can cause serious injury. Keep long hair tied back and avoid loose clothing that could get caught. This is a learning process. It's okay if things don't work perfectly. Be patient and methodical. Read each step carefully before starting. Double-check your connections, make sure all screws are tight. If possible, have a friend who knows drones look over your work. This guide is for beginners. No complex jargon. Let's get started and build something amazing together. The first major phase of our build is assembling the drone's frame. This is the skeleton that will hold all the other components together. Start by carefully unboxing your drone kit. Step 1. Lay out all the parts on your clean workspace. Frame arms, top plate, bottom plate, motor mounts, motors, electronic boards, bags of screws. Take a moment to sort everything into organized piles. Step 2. This simple action will save you a lot of time and prevent you from losing any tiny but crucial pieces. Now we will start putting the frame together. Assemble the motor mounts with the provided screws. Step 3. These are the small plastic or metal pieces that hold the motors at the end of each arm. Attach each assembled motor mount to the end of a drone frame arm. Step 4. Make sure they are secure, but do not over-tighten. You may need small adjustments later. Gently place the motors into their mounts. Step 5. Kits usually include 2 clockwise motors and 2 counterclockwise motors. Look for different colored wires or markings to tell them apart. With the motors in place, we can start on the electronics. Connect the 3 motor wires to the electronic speed controllers, ESCs. Step 6. ESCs control how fast each motor spins. For now, twist the wires together or use temporary connectors. We'll solder them later if needed. Find the main ESC board or the power distribution board and place it at the center of the frame. Step 7. Secure it with screws or strong double-sided tape. Carefully fix the flight controller, the drone's brain, on top of the frame. Step 8. Connect the flight controller to the ESC board using the included cables. Now add the power distribution board, PDB. Step 9. The PDB is like a power strip. It's where the battery plugs in to distribute power. Place the PDB where it's easily accessible. Now that we have the drone's skeleton assembled, it is time to install its nervous system. This involves connecting the radio receiver and organizing all the wires so they do not interfere with the propellers or other moving parts. The radio receiver is a small electronic component that receives signals from your remote control and tells the flight controller what to do. The first thing to do is install this radio receiver. Step 11. Find a good spot for it on the drone's frame, usually near the flight controller, secure it with a zip tie, or use double-sided tape. Make sure the antenna has a clear line of sight and avoid touching carbon fiber or metal parts to prevent signal blockage. Once the receiver is mounted, connect it to the flight controller. Step 12. Use the small cable harness that came with your kit. Consult the flight controller manual diagrams to find the correct pins. Connect the signal wire, connect the power wire, connect the ground wire. Double-check the pinouts carefully. A wrong connection could damage the receiver or flight controller. This link lets your stick movements become flight commands. Move left, move right, move forward, move back. Next, attach the main battery connector to the power distribution board, step 13. This is how the drone gets its power. You may need to solder the red wire and solder the black wire to the PDB. If you're new to soldering, practice on scrap wire first. Make strong, shiny solder joints. Pay attention to polarity, red to positive, black to negative. Reversing them can destroy your electronics. With the electronics connected, add optional safety features. If your kit has propeller guards, install them now. Step 14. These plastic rings clip to the arm ends and form a barrier around the props. They protect your drone, protect your walls, and protect your fingers. Finally, tidy all the wiring. Step 15. Use zip ties to route wires along the frame arms and secure them. This prevents wires from getting snagged or chopped by spinning propellers. A tidy drone is a safer drone. We have a frame and a fully wired nervous system. Now let's give our drone its wings, or in this case, its propellers. This section is all about making sure the motors spin in the right direction and that the props are installed correctly to generate lift. First, take your propellers and place them onto the motor shafts. Step 16. Propellers come in two types, clockwise and counterclockwise. They must be installed in a specific pattern. Front left, rear right, front right, rear left. Your drone's manual will show the correct orientation. Once the propellers are on the correct motors, you need to tighten the propeller nuts. Step 17. These nuts hold the propellers firmly onto the motor shafts. They must be very tight, as a loose propeller can fly off mid-flight and crash. Most drone kits come with self-tightening nuts. Even so, use a small wrench to give them a final snug twist. Before moving on, this is a good moment to do one last check of the motor to ESC connections. Step 18. Ensure that all three wires for each motor are securely connected to their respective ESCs. A loose connection here can cause a motor to stutter or fail. Now for a critical test. Checking the motor direction, step 19. For this test, you must remove the propellers. Never test a motor direction with the props on, as the drone could unexpectedly jump and cause injury. With the props off, connect the battery and use your remote control or flight control software to spin the motors at a very low speed. Observe the direction each motor is spinning. Front left should spin counterclockwise. Rear right should spin counterclockwise. Front right should spin clockwise. Rear left should spin clockwise. If you find that a motor is spinning in the wrong direction, do not worry. This is a very common issue with a simple fix. Step 20. To reverse the direction of a brushless motor, swap any two of the three wires connecting it to its ESC. For example, disconnect the red and black wires and swap their positions. Reconnect them, and the motor will now spin the other way. After correcting any motors, do another quick spin test to confirm that all four are now rotating in the proper direction. This step is absolutely essential for a stable flight. With the physical assembly nearly complete, it is time to connect the brain to the body and give it power. This section is about linking your remote control to the drone and getting the battery ready for action. The first step is to bind the remote control transmitter to the radio receiver on the drone. Step 21. Binding is creating a unique wireless link between controller and drone. Check your radio's manual for the exact procedure. Usually you hold down a small button on the receiver while powering it on, then turn on the remote in bind mode. Once the remote is bound, prepare the battery. We are using the recommended 11.1 volt, 1500 mAh, 3S LiPo battery. Find a secure place on the drone's frame to mount it, usually the bottom plate. Step 22. Use a battery strap or strong Velcro to hold it firmly in place. The battery is the heaviest component, so its position affects the center of gravity. Place it as close to center as possible. With the propellers still off, carefully plug the battery into the PDB's main connector. Step 23. Align the plug carefully. You should hear beeps from the motors as the ESCs in the flight controller initialize. This is an exciting moment. With the battery plugged in and the remote bound, test the electronics. Step 24. Keep propellers off. Turn on your remote, then plug in the drone's battery. Slowly move the control sticks. Watch for lights flashing on the flight controller and check your software for registered inputs. That confirms the remote is communicating. Great sign everything is wired right. Now the drone is receiving your commands. Final step before attaching the camera. Calibrate the electronics. Calibrate the ESCs. Calibrating ESCs makes all 4 motors respond uniformly. Usually power on with throttle at maximum, then lower it. Calibrate the flight controller by placing the drone on a perfectly level surface and running the calibration routine via remote or software. That tells the drone what level is, crucial for stable flight. Follow your flight controller's specific instructions to finish these calibrations. We are on the final stretch. Our drone is built, powered, and ready to be controlled. The last piece of the puzzle is adding the camera so we can capture amazing aerial footage. The first task is to prepare a spot for the camera on the drone's frame. Step 26. You want a location that gives the camera a clear, forward-facing view, unobstructed by propellers or parts of the frame. A flat spot on the top of the drone's top plate is usually the best choice. A flat spot on the front of the drone's top plate is usually the best choice. Make sure the surface is clean so that our adhesive will stick properly. A stable mount is key to getting smooth video. Now, let's attach the camera. We are using the E88 Max drone camera. You can attach it using a small amount of hot glue, step 27, or attach it using a couple of sturdy zip ties. Make sure the camera is level and pointing directly forward. If you are using hot glue, apply just enough to hold it securely without adding too much weight. If you use zip ties, make sure they are pulled very tight so the camera does not vibrate or shift during flight. A wobbly camera will result in shaky, unusable video, so take a moment to ensure it is mounted firmly. Double check that it will not come loose. Next, we need to provide power to the camera. Step 28. Some small cameras like this one are designed to be powered directly from the drone's main battery. They may have a small plug that connects to an available power port on your PDB or into your flight controller. Other cameras come with their own tiny separate battery. If your camera has its own battery, make sure it is fully charged and securely attached to the drone. Check your camera's manual to determine the correct way to power it. Once it is connected, you can test the camera's video feed. Step 29. Most modern drone cameras transmit a Wi-Fi signal that you can connect to with your smartphone. Follow the camera's instructions to view the live video. We have reached the final step, the full final check, step 30. Check every single screw to ensure it is tight. Tug gently on all the wires to make sure they are secure. Confirm that the propellers are on correctly and that the prop nuts are tight. Check that the battery is fully charged and securely mounted. Power on your remote and the drone, and test the camera feed one more time. Make sure all systems are working as expected on the ground. Make sure your screws are tight, wires are secured and clear of props. The battery is charged and centered. Props are correct and nuts are tight. Remote is bound and controls respond. Camera is secure and feed works. You are in a clear, open area away from people and hazards, and you're wearing safety glasses with a plan in case of a problem. You're ready, confident and safe for a successful maiden flight.